afternoon, good morning, or good evening, depending on where you are joining us from today. I'm Nicole Randall with ISEA. Today we are talking hand protection. Recently, ISEA released the ANSI ISEA 105 2024 standard, which is for hand protection classifications. So joining us today is Dr. Andrew Funk. He is with Wells Lamont, and he is also the chair of ISEA's Hand Protection Product Group. He was instrumental in the update of this standard, which has a lot of updates and enhancements as far as our safety standards go. A lot of work went into this. He is the expert on all of this, and he is going to talk to us about it today, about what we need to know about the standard and updates that are in it. Before I hand it over to him, I'll cover just a few housekeeping issues. We welcome your questions throughout the webinar. Don't forget them, put them into the chat box or the Q&A box as you think of them. But keep in mind that we'll address all questions at the conclusion of the presentation. If we can't answer them all at the end, we will be sure to reach out to you to make sure all of your questions are answered. And please keep in mind we are recording this. We will make sure that the recording is available to all who registered and who are interested in learning more about this standard. With that, Andrew, I'm going to go ahead and turn it over to you to kick us off.
All right. Thank you so much, Nicole. So first of all, one of the things to remember, 105, the previous revision was 2016. And, we certainly, a lot of effort went into getting the standard renewed. We renewed it back end of November, start of December of 2024. And so I just want to thank the fellow people on the Hand Protection Product Group for all of your hard work in getting this done. So just as a bit of a reminder as far as hand protection and what 105 is here for. So we have about 104 million, give or take a little bit, of American workers need hand protection. That's just in the US. That doesn't include Canada and some other areas that do follow 105. 70% of those workers don't wear hand protection and 30% don't wear the right kind of gloves. One of the things that we try to do with 105 is provide some categorization and classification to make it easier to be able to select the right hand protection. Of those, they think that about 71% of those injuries could have been prevented with gloves, particularly the right gloves. If you look over there, of those hand injuries, about 454,000, that was back in 2022. 45% of those are cut, laceration, or puncture, which are kind of the primary mechanical protections that are listed in 105. So that's something that we're going to address in a little bit and just take a look at those standards in particular, those test methods. Again, here is a partial list of the people who were involved in getting this standard renewed. Thank you again to everybody who had some involvement here. So let's look, first of all, at some of the changes in 105. In particular, we've got a new labeling requirement. Then we're going to talk about cut, abrasion, puncture, some additional test methods that we've got in 105, some updates we've got for contact heating, and then finally, some resources that we have available for safety professionals and end users. So that is our new symbol. Obviously, we've got some labels on there too, but our new symbol is the ANSI ISEA 105. It's a pentagon symbol with cut, abrasion, and puncture on there. So just as a reminder, 105 provides a classification system for both hand and arm protection. So that includes sleeves. There's mechanical, chemical, thermal, and some other hazards in there as well. And there's detailed performance ranges so that users and safety managers can select the right glove or sleeve. So one of the problems that we've had in recent years is that the back of the hand and labels for a lot of gloves have become extremely crowded. This is a glove that I just put some symbols. This is very similar to what has been out on the marketplace previously. It just starts to get really crowded and really hard to read. So what we've done is introduce new marking requirements that standardizes our key performance properties, cut, abrasion, and puncture, into one symbol. And that symbol is the ANSI ISE 105 marking that was introduced in 105-2024. So you can see there, right at the top, we have cut, to the left is abrasion, and to the right is puncture. Now, this is new. You're going to be seeing this. If you haven't seen this already, you're going to be seeing this a lot throughout the industry. I've already seen quite a few gloves that are out there that have the symbol on there, as well as some marketing and websites and stuff like that. So here are the guidelines on that marking. That's a pentagon symbol with evenly angled sides, cut, abrasion, and puncture ratings. That title is centered over the pentagon. Now, you'll see sometimes, and even in this webinar, you'll see a year on some of the markings. Now, that year is optional, but on product and packaging, typically you would see it. You would not see that year on the product and packaging. Where you will see it is on websites, white papers, blogs, technical sheets, specification sheets. That cut rating is top center. That rating is a little bit bigger in font than the abrasion and the puncture. Again, left is abrasion, right is puncture. If a classification wasn't tested or isn't applicable to that product, you'll see an X right there. The X doesn't mean that it doesn't provide any of those attributes. It just means that that either wasn't tested or wasn't chosen to be tested or isn't applicable for that kind of product. We've requested that people use a sans serif typeface. We've given examples of, like, for instance, Montserrat or Open Sans, but that isn't defined in the standard what typeface you have to use. It just should be a sans serif. Now, let me go into the badge anatomy and when to use it in particular. So, again, on product and packaging only, such as labels, markings, external product packaging, like a poly bag around a glove or a sleeve, you have the option of using the standard without the year. So you'll see ANSI/ISEA 105. You can use the complete name with the year, but that is optional. Oftentimes, it's a little easier to just have ANSI/ISEA 105 because of space constrictions. A lot of times, especially on the back of the glove or on a label, putting that full title with the year can be a little bit restrictive. So you have the option of not including the year. Now, on general use references, websites, videos, blogs, white papers, it is recommended that the entire standard name be used. ANSI/ISEA 105-2024. Now, I've seen some of them where the 105-2024 is to the side of the ANSI/ISEA. I think we would recommend that you have it like this, but again, the important part is that the date is included on general use references. Now, one of the things I wanted to get into a little bit here are non-compliant uses. So ANSI themselves have updated their recommendations, their guidelines for use of their word mark. Now, you'll see a lot of things on here that people in the industry use quite a bit. ANSI cut level, ANSI cut, ANSI certified, ANSI level. According to ANSI, these are now non-compliant uses of the ANSI word mark and must be avoided. That's not even should be avoided, it must be avoided. You'll even see something like ANSI 105-2024. ANSI has provided the guidelines that they want to see ANSI/ISEA 105-2024 or ANSI/ISEA 105. Part of the reasoning for this is that ANSI wants to make sure that they're not seen as certifying or approving any of these products. They are a standards development organization. They're not a testing organization. So they have not certified a product. And I think you'll see out in the marketplace sometimes people say it's an ANSI certified product. ANSI wants to make sure that that's not the message that's getting out there. So again, if you look at this list, and it's not completely exhaustive, these are things now that must be avoided and are non-compliant. Now, according to 105, products must display classifications for protective attributes to comply with 105. That information should be visible and understandable. It can be, for instance, back of the hand or label. If those aren't possible, then the next level of product packaging, like a pouch or a poly bag. That marking system will help users choose the right protection for their needs. Obviously, when they can choose the right protection, then that promotes safety and compliance. It's really the reason why we've got this marking and why 105 now has some conformity assessment to be able to say, okay, if you're in compliance with 105, this is what you have to do. Now let's get into a little bit of review of our primary mechanical protection. That is cut, abrasion, and puncture protection. If you look at that picture, that's actually a screen grab from a microscope picture that I did. That is a textile with a blade running across it. So these are the primary mechanical risks that we talk about in 105. Cut resistance, abrasion resistance, puncture resistance, and they're the three that are on the new symbol. So as a bit of a review, the standard for measuring cut resistance uses a machine called a tomo dynamometer. Say that 3 times fast or 5 times fast. It's not easy. Basically, all that means is cut test force measurement or cut force measurement. What we're doing is drawing a blade across a specimen. When that blade makes connection, an electrical connection with a conductive strip under the specimen, it stops the drive, and you can measure how long it took with a certain load on the system, a certain weight, how long it took in millimeters to get across that specimen. Now, the test results are in grams force. That's something that I think sometimes isn't always clear to people out there. A lot of times you'll see, well, what are my grams? Technically, this is actually grams force. There are a certain amount of grams that are on the plate that is used for this test. That is actually doubled, force doubled by the equipment into pressure on the blade, that force on the blade. And that cutting load measures the amount of force required to cut through a 20 millimeter distance. So each F2992 test has 15 cuts. From those 15 cuts, that force calculation is done. And then 3 F2992 tests are averaged to obtain the ANSI ISEA 105-2024 cut level. Now, that on the left is your typical, the most common tomo dynamometer that's out there, the TDM 100. There are a few others. We have recently in the 2023 F2992 standard approved a machine from Satra as well. But the RGI is the primary device that we're using to measure this. Now you see ISEA has made this really handy chart here on the right, and it's actually available. We'll talk about some of the resources that we have available. It's available on the ISEA website. So you'll see like the different cut levels, A1, A2, A3. Those are protections against scrapes, small parts assembly. You won't have heavy blades, heavy amounts of cut protection with these A1, A2, A3. This is light/light medium. Now for A4 and A5, these are protections against cuts for stitches that would be required. Appliance manufacturing, HVAC, automotive assembly, metal fab, packaging, warehouse, aerospace. And then you get into our higher levels of protection, A6 through A9. These are not only cuts where which stitches would be required, it could be occasionally somewhat extreme injuries as far as cut or lacerations. Again, we have food prep and processing, meat processing, sharp metal stamp, metal recycling, pulp and paper, aerospace. These are more extreme environments. For our abrasion resistance, that's done using a taber. This is one of the models of taber. Now you can see on here, you have a specimen holder, a vacuum that comes down, some auxiliary weights that go on there. And the way this works is that your specimen's on there, there are abrasive wheels that are mounted. You can see that on the left-hand sample there. The sample is spun around, and those abrasive wheels run round and around and around and wear down that sample. The specimen holder turns around and the wheels turn above it and abrades the material. As those specimens get more and more cycles, it will wear down that material and eventually wear through the material. And depending on whether we have a coated or uncoated sample, we will evaluate when it breaks through, and that's our endpoint, our cycles to failure. Again, the testing is performed until failure. The endpoint for knit gloves is when a yarn breaks. That's really clear. For dipped or leather gloves, it's when a hole appears through the material. The standard indicates when it's worn through the coating and the liner. So it's not just when the coating is worn down, but actually when it's worn through the coating and the liner. Now, I know sometimes some people will say, well, when the coating is worn off, then they dispose of the gloves. But according to the standard, at least, you still have protection against abrasion when that liner is still in place. So the standard indicates that when it's worn through the coating and the liner. The standards used are ASTM D3389 for coated gloves or sleeves and D3884 for uncoated gloves or sleeves. And on the right-hand side there, we have our classifications. So under 100 cycles, 100 revolutions, it doesn't provide a rating. And you can see this, a 500-gram load all the way up to 3,000 revolutions. If you're getting over 3,000, you go back, switch to a 1,000-gram load, and rerun the test. Our highest classification is when it gets over 20,000. It's quite a lot of abrasion resistance. Now, puncture, here are a couple of different probes that we have that we use for different kinds of puncture resistance, and you can see it compared right there to a number 2 pencil. What 105 typically uses is the EN3D8 probe. That's the third one down from the top. It's a rather large nail is the equivalent there. The F1342 probe in the ASTM test is a little bit smaller. That's more like a finishing nail. And then we've got a comparison there to a 25 gauge needle used in hypodermic needle testing. So again, our probe for EN3D8, which is used in 105, is a large nail. That's the protection that it's modeling here. And on the left-hand side, you see that fixture in place on a test stand. So that fixture is brought down into the material, and when it is punctured through the material, that's when the test ends. The puncture is measured in newtons, which is another measurement of force. This is obviously non-hypodermic needle test. So you can see we've also got, and this is also available from ISEA, the different classifications, 1 through 5, different puncture levels for those classifications, and some general applications that would be appropriate for those puncture levels. For example, puncture level 1, light construction, material handling, parts assembly. When you go to all the way up to 3, you've got some more heavy construction, light glass handling, light metal stamping. up through 5, where you've got mining, heavy construction, demolition, fabrication. That's quite a lot of puncture resistance right there. Now we're going to talk a little bit about, I'm going to say a little more recent advancements and some of the other test methods that we have in 105. We've spent a long time talking about cut, abrasion, and puncture, but there are quite a few other standards and other test methods that are in 105. For example, you've got hypodermic needle puncture testing, and we're going to talk about that in just a second. Chemical permeation, chemical degradation, ignition resistance, which is flame or FR, heat degradation resistance, and conductive heat resistance or contact heat. We're also going to talk about that in a minute because we do have some updates to how 105 looks at contact heat, specifically some of the material requirements. So looking at hypodermic needle puncture testing, again, we have that same picture from before. You can see that that needle is quite a bit smaller than the probes we're using for, quote, regular puncture. The test method is ASTM F2878. The most recent one that was included there was the 2019 version of the standard. The primary gauge that we're using for hypodermic needle testing is 25. It does list also 21 and 23 in the ASTM standard, but ISEA 105 specifies, and the primary one in F2878 is the 25 gauge. The test method still works for 28, your thinner needles or your thicker needles. But as far as getting a 105 standard classification, that is 25 gauge needles only. It's a really common needle, intravenous drug use, intramuscular hormone administration, stuff like that. Very common, commonly used needle. Again, just like the other kind of puncture, the test stand presses the needle through a material and measures the peak load when it breaks through. Now, you'll see here the amount of force that required to put a needle through a specimen is a lot less than it was for our, quote, regular puncture. Those, were 100, 150 newtons. Here, our top classification is 10. That's quite a lot of needle stick protection, as it turns out. These needles have quite an easy time of getting through a lot of material. So it takes some really sophisticated materials to be able to block the hypodermic needles and give you hypodermic needle puncture resistance. That's a picture on the left-hand side of a hypodermic needle on the test stand. That picture is actually from an upcoming ISO standard that is related to the ASTM standard that's used in 105. Next, we're going to talk a little bit here about updates to our contact heat standard within 105. So there's new items as far as the testing technique, but especially as far as material evaluation. Now you can see, although some of it is cut off a little bit, but that picture on the left, conduction is direct heat transfer. Convection is the movement of molecules. Radiation is radiative heat off of a substance, but conduction is direct contact. So we have here the 105 heat levels. They start, at 80 C, which is approximately 176 Fahrenheit. The standard is written as far as Celsius is the primary unit of measure. But obviously, here in the US, we're typically using Fahrenheit. So if you look at that translation, that's approximate on the right-hand side. So for instance, 80 to 139, it's about 176 to 283 Fahrenheit. So the heat levels, the contact heat temperature rating, is the recommended temperature using the ASTM F1060 test, at which the time to second degree burn is greater than or equal to 15 seconds, and the alarm time is greater than 4 seconds. Now, the alarm time is the time between the first indication of pain and time to second degree burn. Yes, that is second degree burn. I talk a lot about this. That data was actually collected on humans back in the 50s. Obviously, that would be completely unethical to run now. But at the same time, we have this data and we're actually able to compare how long, given our change in temperature over time or heat flux, we can calculate how long it would take for somebody to feel pain and how long it would take for somebody to feel a second degree or get a second degree burn. And we have a 4-second time. Essentially, that alarm time is not only to remove, take whatever you're holding, set that down, but also to get the gloves off, because oftentimes the gloves will actually be storing heat. There's like this stored thermal energy within the gloves. So not only do you have to set the item down that's hot, but the PPE needs to come off as well. Now, that third paragraph there is important. The classification shall be at the temperature in which there is no evidence of charring, ignition, melting, dripping, and separation, and there's no shrinkage greater than 5%. So that part is new. It indicates that the glove or sleeve shouldn't have degraded during the conductive heat test. And we're going to go into that now because this part is important and it's new. And I know there have already been some questions. I had somebody email me about this the other day, so I want to make sure that it's really clear here. Again, no evidence of charring, ignition, melting, dripping, and separation. By the way, that's one of the standard F1060 testers on the left-hand side. So the reason why we made these updates to the 6.3.3 part of 105 was that you could actually pass this test and have the glove completely melt. And to our minds, that was not a successful test. You don't want the glove, like an end user, to have a glove that's melting on them and that glove still be considered to be a successful protection against that heat. That was not seen as a successful test, because if the textile melts, that's a hazard. Obviously, we've also got a shrinkage requirement now. Now, that how that shrinkage is measured is still left to the user of the standard. It can be measured in a single direction. For example, length. That's how ASTM D2102 measures fiber length. We may provide some updates and clarification on this, but as of right now, it's left to the user of the standard. But that shrinkage should be no more than 5%. Again, you don't want the gloves deforming while you're using it at that recommended temperature. There also should be no significant evidence of charring. Now, there's been some questions on, well, what does that mean? Look very specifically, convert to charcoal or carbon, usually by heat. It's carbonization. That's not a slight discoloration. You'll see sometimes a glove slightly discolor. That doesn't mean that it's lost its protective elements. Kevlar sometimes will discolor a little bit when exposed to higher levels of heat. Doesn't mean that it's lost its protection. Slight discoloration does not indicate charring. Heavy discoloration is charring. If you look at, for instance, flame testing, char length is taken to mean like a burned area of the sample. And that's charring is burning. And what happens with contact heat is if the heat gets high enough, the sample will start to have small areas of ignition. And that will be charred areas. So you're not talking about just discoloration, you're actually getting charring on there. We wanted to make sure that, like, somebody has a glove on and it's at 500 degrees. Well, if that glove starts to smoke significantly and there starts to be charring, that is, again, not a successful glove for protection. Now, if you look here, here's just an example. And we wanted to provide an example here so that you would say, okay, this is what a conductive heat test looks like up close and personal. So this is just a random heat glove represented on the right. After testing at 550 degrees, it was found that the time to pain, according to the chart, was 18.33 seconds, and the time to burn was 24.44 seconds. with an alarm time of 6.11 seconds. Now you can see, first of all, our time to burn is above 15, which is good. And our alarm time is greater than 4 seconds, which is also appropriate for the standard. As such, the glove qualifies for a 105 rating. In this case, it would be level 4 classification for conductive heat resistance because it qualifies as far as the time to burn and the alarm time at that temperature. Now, a lot of times what you'll see is just a level. This is what's going on behind that level. That recommended temperature of 550 degrees means that you've had at least 15 seconds time to burn and at least a 4-second alarm time at that temperature. So when you see that kind of recommendation, that's what's behind that. So I've seen some of these ANSI ISEA 105 heat levels out there. We're certainly starting to see this this part of the standard being adopted more frequently, especially here in the US. We certainly like to see that because I think it is very descriptive in how it goes about the conductive heat resistance. Now, this isn't having to do with convective heat resistance or radiative. This is just conductive. Now we're going to go into just a little bit as far as the resources for safety professionals and end users. We've got a lot of tools that we've brought out here to make sure that people understand what 105 does, how to look up, especially the new classification symbol is going to be a challenge and a hurdle for education. And so ISEA has brought out a lot of information, a lot of educational tools to be able to take a look at this and to educate our sales staff, our end users, our distributors, everyone within our chain going down to the end user to be able to make these decisions so that we can protect our workers. For example, we have upper left-hand side, the American National Standard for Hand Protection selection criteria. So that is the primary labeling guidelines. They are also actually in the standard, but that is a labeling guideline that can help everyone when creating these new labels and going into what's required, or if you're an end user or a safety manager, okay, what does this new symbol mean? I'm seeing these 3 numbers on here. How do I interpret this? It isn't always, if you just look at the symbol, it isn't labeled cut, abrasion, puncture. This is one of those things that through education, we will let everybody know what those 3 symbols mean. And that everybody, after a while, it will become a matter of rote memorization that you know, okay, there's cut, there's abrasion, there's puncture. We have on the upper hand, right hand, the key to hand classifications. Again, it's a little bit narrower just looking at these hand classifications, looking at the resources as far as, okay, A1, A2, A3, A4, what do these all mean? You look at the bottom left, toolbox talk. That's, talking about hand and arm protection in general a little bit. Bottom right, 5 facts, hand and arm protection. So this is all available at the ISEA website, safetyequipment.org/gloves. And with that, Nicole, I know that you had some stuff that you wanted
go
to
ahead and turn it
show
over to the
here as
next
far as.
slide. Turn
Yeah.
it over to the next slide real quick, and I'll touch on this shortly. Actually, all of our attendees today are getting a little sneak peek at a new resource that ISEA will be releasing soon. Many of you may be familiar with our QSSP program. This is a training program for safety sales professionals. And we are doing a new part of this program called QSSP Essentials. And this program will essentially provide small little nugget training programs that you can do virtually on demand, and they specify on certain worker protection categories. And one of them will be on hand protection. We are set to release this in the next week or 2, so stay tuned. If you don't already subscribe to ISEA's newsletter, be sure you do that so you know when we launch this and when it will be available for anyone to take. It goes into a deep dive of all of the various categories of hand protection and how you can choose the right fit for your workers and to ensure that you are selling appropriate. I'm also going to go ahead and share my screen here, Andrew, because I want to touch on, I'm just trying to find my application of this website. Here we go. Can you see my browser here?
There we go.
Okay, perfect. This is the landing page that Andrew was chatting about. You can see the URL up here. Also go to safetyequipment.org/gloves. And this is where all of those resources live for you to download for free. I also want to touch on a campaign that we've just launched. We are doing a glove giveaway. This is targeted to the end user, so please feel free to share. Here, folks can go and enter to win safety gloves. And ISEA will be sending those out to the first couple hundred people who sign up to receive samples of gloves provided by a lot of ISEA members. You can see who's participating there. So thank you to those of you who may be on the webinar today who are participating. And if you are a user who is on the call today, please go ahead and fill out the form and make sure you get your free glove sample. We go down here through the resources. This is all the stuff that Andrew touched on. Here you can find where you can purchase the updated standard for 2024, some of our other glove standards, and all of these resources we were chatting about. Your key to hand classification poster, labeling guidelines for providers of hand protection to conform to the updated standards, fact sheets about the standards, a cut resistance calculator as well, and some other information that you can use for hand protection. So with that, Andrew, as you can imagine, we have tons of questions. So
Yes, I've been looking at them a little bit.
let's pick the one that's been coming up the most, a conformity date or a grandfather period. Can you touch on that a little bit?
Yes. First of all, while we look at this, I'm going to bring back up just so that everyone can see.
Please.
That marking, and I'm just going to leave that up there for a while.
Wonderful.
That way, anyone who needs to just take a closer look at this can have that up on their screen.
Perfect.
So as far as a time frame, there's a couple of different time frames that we're dealing with here. First of all, let me go into a little bit on the ANSI word mark, because that's probably the most crucial one here. ANSI is giving people some time to adjust to the new requirements on their word mark. Now, that said, it's not going to be forever. I think they've talked about right now 6 months to a year. Now, ANSI has not been terribly aggressive as far as inside the United States, but they have been somewhat aggressive as far as customs. So I think everybody needs to make sure that anything that they are bringing into the US, that as soon as you can, get those markings in line and in compliance with the ANSI word mark. Again, they have said that they're going to give quite a bit of time to allow everything to work through the system, because certainly they understand. And when this was all discussed, they understand that people order these things months and months in advance. And then they go through the supply chain, they get on a boat, they come here, they're unloaded, they go through customs. It takes some time to make these kind of adjustments. So as far as that goes, there is a time frame in which to get in compliance with the ANSI word mark. Now, as far as,
and I'll just hop in there, Andrew. I know you included the URL on one of your slides about their policies and regulations. So you can just go to the ANSI website to learn more about how to conform to their rules.
Correct. As far as 105 goes, so obviously the standard is now 2024. If you want to be in compliance with 105-2024, that's pretty much right away. Now, if you have existing inventory that is still compliant with 2016, it is still in compliance with 105-2016. That's not a bad thing. That is just the older version of the standard. But to be in compliance with 2024, it needs to be updated.
As well as the new testing methodology.
As well as, especially with contact heat. Because, for instance, cut, abrasion, and puncture, we have updated our standard years as far as the test methods, but nothing really has significantly changed on those test methodologies for cut and abrasion and puncture. However, we now have a marking, and that marking, if you look at the levels of conformity assessment within 105, and I can spend just a second. So conformity assessment is basically, are you adhering to this? Previously, this was all left up to manufacturers. And in a sense, it still is. There is nothing in governmental regulations like it is in Europe. However, when you say you're in compliance with 105, there are now some guidelines and some things you have to follow. I'm going to address one of the questions right away. It kind of will jump forward. I don't know if, Nicole, this is on your list, but
No,
because
go
we
ahead.
have this shape up right now, I'm going to address one of those questions right away. Do we have a new marking for chemical, heat, flame? No, we don't. But we are addressing it. It was something that came up in our most recent ISEA meeting. We have a working group that is looking at this problem to provide some guidelines. We don't want to have multiple Pentagon badges out there, multiple Pentagon symbols, because I feel like, and again, this is all to be determined, but I feel like this is very straightforward. I don't want to confuse the issue, but we understand that people have markings out there that they want to use for these other classifications. So we have to make sure that we give some guidance, and we're working on that. I will say, though, one thing you can do right away, if you're using a shield, if you're using some other kind of symbol, you do need to do a couple of things as far as the ANSI word mark. ANSI/ISEA 105 on product and packaging, and the full title of the standard on websites, blog posts, all that. So even if you have your own like flame shield, it's got to have this stuff on there as far as the one ANSI/ISEA 105 on product and packaging. It's no longer compliant to say ANSI flame level or ANSI flame or ANSI heat, something like that. So it's really important that everything be in compliance in that way. I'm going to address another question here I saw that was impact. No, we did not include impact. Impact is still not in 105. It's a separate standard, 138. Again, that's something under discussion going forward. It may become part of 105 at some point, but currently it is its own separate standard with its own separate markings. Now, the 138 impact markings are even more restrictive. You have to get third-party testing for that. The conformity assessment for that is more restrictive than 105. But for right now, we do not have an impact mark as part of this.
And that standard's also available on the website that we showed you that I put in the chat box as well.
Yes.
There. Let's continue our conversation on heat, Andrew. Someone's asked us here, thing there, there are gloves in the marketplace that go up to 700 to 2000 Fahrenheit resistance. Why aren't there higher ratings in our standard?
So that's a great question. I've actually talked to there's been some discussion over at ASTM on this, because ASTM F1060 is the test method for this. And there's actually an ASTM subcommittee on flame and thermal. And that's where that standard comes out, that test method. We've talked about it. Certainly the methodology of time to pain, time to burn works no matter if you're at 500 degrees or 1000 degrees. The real problem right now is actually an equipment problem. Finding a hot plate or some similar kind of device that goes up that high. We just don't have a consistent set of equipment that can run that high, that can do these kind of things. The other thing is that that's pretty specialized stuff right now as far as that kind of protection. Certainly, if the equipment and the test methods become available, ISEA, we will look very closely at incorporating that into future versions of 105 because certainly there are gloves out there that are working at these temperatures. We want to make sure that people are protected when they're working with something that's 1,000 degrees or 1,500 degrees. Right now, I think, unfortunately, it's a little bit of the wild, wild west at those temperatures. People are marking things, and I'm not sure. There's certainly no standard that I'm aware of or test method I'm aware of that they're using. We want to try to develop something like that, but certainly right now there's an equipment issue that's a kind of our primary obstacle for getting that incorporated.
Thank you. Another question we have here is about arc flash protection. Is there anything in the standard about that, or has the hand protection product group discussed it?
So we certainly don't. I'm trying to remember just off the top of my head. I don't have a copy of the standard. We have references in the back in the appendix of the standard for other test methods that aren't within the scope right now of 105. There is some very detailed arc flash testing available. I think it's an ASTM test method, if I'm not mistaken. Yeah, Susie got that. ASTM F2675. It is rather detailed. It does provide levels. I think as of right now, we didn't feel like there was anything else that needed to be done or needed to be appended as far as arc flash in 105. It's certainly something that we're aware of, certainly something that, could possibly be incorporated. But as there's an existing standard that's working, I think right now the decision was made, we just wouldn't touch that one.
Thank you. Here's an interesting, a technical one for you that I'm sure you'll have the answer to. What's the difference between ASTM 5299215 and 5299223?
The short answer is not a lot. So we did do a revision. We're actually, almost all these standards development organizations are required every so often to do renewals. And we looked at 15 and realized we did not have a precision and bias statement. That means that's how precise is your measurements, how precise is your test method. So the primary thing that we did in F2992-23 was to look at precision and bias. We have that in there now. So you can go and you can take a look, and there's a research report that can be downloaded online that can look at the full research that was done on that cut resistance method. That's the primary thing that was done. Other than that, there's not a ton that was changed as far as the core test methodology. It's a test that's working pretty well. We have some additional updates that you'll probably see within the next year or so. But again, nothing that changes the core methodology.
Good question. Does this new standard cover proper fit or care of hand protection?
It does not address fit. It's something, for those of you who were at the latest ISEA meeting, it is something that as an industry we're talking about quite a lot. Not only, fit in the general population but fit for parts of our population that maybe hadn't been addressed within the trades, within certainly the workers out in the field. Fit is certainly a really important thing. Having a standards classification and performance classification of fit is tricky because how are you going to evaluate fit? It's certainly something that we focus and we pay a lot of attention to. And if somebody has an idea on how to classify fit, that's certainly wonderful. But right now, we don't have a standard guideline. That said, ISO, like the EN standards do have some stuff about fit. It is very broad. They have, okay, what does the palm length have to be? There are some specified requirements, but it's really general, and honestly, does it work as well as it could? Probably not. It's something that we are paying a lot of attention to as an industry. I guess that's the short answer. The long answer is it's something we could look at.
No, I think that's great. And, something to keep in mind is that ISEA is always putting together resources for users that offer guidance and best practices in areas like this. So keep an eye out for those as we continue to make those to talk about best practices for fit of gloves and especially for cleaning and care. Another question for you. If we ask an ISO 17025 accredited lab to carry out the 105 tests, is this update going to be included in that now?
So anyone who is going to, there's kind of two questions here because 17025, if they are testing conformity to 2024, 105-2024, they need to be using this standard with all of the new markings and everything. If they are testing conformity to 2016, which at this point, I'm not sure why they would be doing that, but I could see that, then they would be following that standard. But again, a 17025 lab, all that means is that you've been accredited by ISO and you follow certain procedures. If you're testing conformity to 2024 version of 105, you need to be testing to this standard with these updates. It's pretty straightforward. You will see sometimes some third-party labs, especially in Europe, who they'll see some of these ANSI markings and they freak out a little bit, for want of a better term, because it's not within all of their purview to actually test conformity to 105. That said, it is pretty straightforward testing conformity to 105. The markings are clear, the test methods are clear. Either they can test it themselves or they can accept declarations that it has been tested. I saw something on there too. I just wanted to reiterate that, again, these markings, it's on product and packaging is 105. You don't need the date necessarily, although you can if you want. And the -2024 on websites, video, blogs. On the product and packaging, that is either on the back of the hand, if it's like a palm dip, for example, or on a label. It can be on a label. Or if it's not available on either of those, the next level of product, which is, for example, the poly bag or something like that.
Right, I'm just looking up. We've got a lot of questions coming in about the use of the ANSI logo and mark. So I am going to put into the chat that website that you had put in the deck, but I'm going to go ahead and put that in the chat now because I know some folks are really curious
Right.
about that. So we recommend definitely looking through ANSI's recommendations and guidelines. ISEA has created resources for its members on this issue as well. If you are an ISEA member and have not seen these resources, please reach out and we'll make sure that you get them.
And just to reiterate on this one, the big picture here is that ANSI doesn't want to be seen as certifying product because they don't. And so and I think they also saw kind of a little bit of the confusion out there in the marketplace as far as what this all meant. You know, if you look at those symbols on the right-hand side there, they're basically all shields, but they say so many different things. And I think they just wanted some clarification, honestly. They wanted to make sure people didn't think that ANSI was out certifying things. That's why these new compliance guidelines have been published by ANSI. So if you go to that website, it's in the chat, you can look at exactly what ANSI is saying. But what we said here, as far as on product and packaging and on websites and blogs and stuff like that, ANSI/ISA 105 on product and packaging, ANSI/ISA 105-2024 on websites, blogs, all that. If you do that, we're not going to tell you you're in compliance, but you can see that, you know, according to the ANSI, you can look at the criteria that would generally indicate compliance.
Great. Well, we are just about at the end of our hour. I'm going to end with one last question for you. What about cold stress? Andrew, we've talked about, you know, conductive heat, but what about cold stress. Is there anything about that in the standard? And if not, are there other resources available?
So we do again in the annex or appendix, I think it's in an appendix of the standard, we do have some cold testing resources available. Primarily right now, we've looked at it and we've talked about it as, both at ISEA and over at ASTM. One of the big challenges first is everybody's looking for temperature ratings. Well, for heat, conductive heat especially, it's fairly straightforward. For cold, it's much more complicated because what you're dealing with there is everybody's metabolism is different. So they're providing a lot different input into the glove as far as how much heat they're putting in. And so that's one of the big kind of obstacles. It's not an insurmountable obstacle, but it's a big obstacle in looking at temperature readings. Right now, the only real test that's available for performance classification of cold is EN 511. I think the latest revision is 2006. That has convective cold, contact cold, and water permeation. And the water permeation is basically indicating whether, water can get in. Obviously, when you're talking about cold, water permeation is a big deal because if your hands get wet and they're cold, it's a problem from a safety standpoint. That's currently the only test method available. It does not provide temperature ratings, but it does provide relative ratings based on the testing that they perform. That currently is what resources are available.
Great. Well, with that, we are going to wrap things up. We so appreciate everyone who joined us today. And Andrew, thank you so much for being here
Sure
with
thing.
us and our attendees to talk about this. I know there may be more questions, more clarifications needed. Feel free to reach out to ISEA. We'll be happy to facilitate those and get you the answers that you need. You should receive a pop-up evaluation form when this is done. Please let us know how we did, how we might improve these webinars for you, and ideas about any future education opportunities we can provide. Once again, thank you to everyone who joined us. I'm Nicole Randall with ISEA. Have a wonderful afternoon. Take
Thank you
care.
so much.